Hi everybody, and welcome to lesson 2.7, Fossil Fuels. The content in this video is aligned to the third edition of Environmental Science for AP and covers information from College Board Unit 6.5. Now that we have a solid understanding of the general types and uses of energy resources, let's begin a deeper dive into specific resource types. Here we will focus on fossil fuels. This leads us to the content objective of understanding that humans use energy from a variety of sources, resulting in positive and negative consequences. By the end of this lesson, you should be able to describe the formation of fossil fuels, describe the use and methods of fossil fuels in electricity generation, and describe the effects of fossil fuels on the environment. Which leads us to being able to answer the guiding question of why are fossil fuels so hard to remove from energy consumption? It's important to begin with an understanding of the structure and formation of fossil fuels. All fossil fuels are the remnants of long dead organisms. Much of these resources were formed hundreds of millions of years ago. There are several conditions that are required for the formation of these kinds of resources. The presence of organic matter that undergoes anaerobic decomposition, excessive heat and pressure, and an extended amount of time. It is for this reason, the length of time required for these resources to form, that we categorize them as non-renewable. The time required for them to replenish is so extensive that they are effectively finite. One of the major differences in the formation of coal and petroleum and natural gas is the condition of the early environment. Coal was formed primarily from the remnants of ancient swamps and bogs. Over time, the swamps were covered over with dirt, increasing the heat and the pressure. Organisms trapped within them underwent anaerobic respiration and decomposed the material. After enough time with enough pressure, coal began to form. Based on the length of time and the amount of pressure, one of three types of coal were formed: peat, bituminous coal, and anthracite. Peat is very low quality organic matter that is similar to the early stages of coal formation hundreds of millions of years ago. It can be burned, but it is often too damp to provide a good source of energy. Bituminous coal is of a higher quality, largely because it was able to undergo even longer periods of decomposition and pressure. However, it is sometimes contaminated with things like sulfur and other compounds. Lastly is anthracite, which is the highest quality coal. It has undergone the longest time under intense heat and pressure, which is why it is often found in deposits very deep in the earth. Natural gas and petroleum are the remnants of ancient sea creatures that were covered over by sand and silt. This is one of the reasons that natural gas is often found in shale formations, as heat and pressure can convert silt into shale given the right circumstances. For fossil fuels, there are 5 major steps of getting from the reserves to the production of electricity. Reserves have to be identified and located, which is easier in some places than others. When the material is close to the surface, it is much easier to identify. Today, the vast majority of reserves have been identified through LIDAR, sonar, and extensive GIS data. Then the material has to be extracted. There are several ways in which we do this, which we will discuss in a brief moment. After extraction, the resource has to be transported to the refinery, where it is processed to remove impurities and make it appropriate for use. Only then is the fossil fuel put to its intended purpose, electricity generation, or other industrial purposes. Let's assume that the final destination of the fossil fuel is a power plant. Here we see the steps required to produce electricity from a fossil fuel. After the fossil fuel is extracted and refined, it is combusted. The combustion produces large amounts of heat, which is used to boil water. The boiling water produces steam, which is collected and funneled through an increasingly narrow pipe. The narrow pipe forces the steam under pressure, increasing its force as it is released onto a turbine. The turbine spins, which produces mechanical energy. The turbine is connected to a generator, which takes the mechanical energy of the spinning turbine and converts it into electrical energy, which can then be released onto the electrical grid. Through this process, chemical energy stored in the fossil fuel is converted to mechanical and then electrical energy. The method of extracting a fossil fuel greatly depends on the type of fuel and the location in which it is found. For coal, the most effective and efficient method is through mining, whether that be surface or subsurface. Petroleum is most effectively obtained using drilling and pumping the liquid to the surface using a variety of heavy machinery and rigs. Drilling is not confined to land. Many companies and countries engage in what is known as offshore drilling. In this practice, semi-floating rigs are built in the oceans with drilling equipment that reaches down to the ocean floor, where it pumps up crude oil. This is the structure of the Deepwater Horizon rig owned by BP, which had a catastrophic failure and oil spill in 2010. Natural gas is obtained through a process known as hydraulic fracturing, or fracking. Hydraulic fracturing, or fracking, is the process used to release natural gas deposits from rock. This is done by pumping high-pressure water, sand, and chemicals into the ground through a pipe. The combination of pressure and chemicals serves to break apart the fragile shell in which the natural gas is trapped. The gas then flows out into the pipe, where it is pumped back to the surface. Fracking is done mostly on land, but it has been proposed to be done on the continental shelf near coastlines. Now that we've looked at the methods of extraction and uses of fossil fuels, let's talk about the environmental impact associated with them. Because they are relatively abundant, easy to access, and have a high EROEI, fossil fuels are widely used throughout the world. Their continued use, however, will quickly lead to depletion of reserves and require that we use versions of these fuels that are of lower quality. For example, burning peat rather than bituminous coal or anthracite, which have greater environmental impacts. Here, we identify these impacts based on their primary target. It is well documented that the burning of fossil fuels contributes significantly to carbon dioxide emissions. This carbon dioxide plays a direct part in accelerating the greenhouse effect and leading to global climate change and, indirectly, to ocean acidification. Incomplete combustion of fossil fuels also releases carbon monoxide, a colorless and odorless gas that is extremely deadly. Fossil fuels are also rife with impurities that must be removed before use. However, it is impossible to remove them all, and the refining process has its own issues with these impurities. Specifically, fossil fuels are responsible for the release of a variety of sulfur compounds that can contribute to the formation of acid rain. Lastly, the refinement process and other uses of fossil fuels releases what are known as volatile organic compounds, which are carbon-based compounds that evaporate rapidly into the air and pose serious health hazards. The primary impact of fossil fuels on soil comes from the extraction and transportation process. Every method of extracting fossil fuels causes disruption of habitats and can contribute to or cause erosion and topsoil loss. Fracking can lead to chemical infiltration of the soil, which can drastically change the pH and directly cause the death of plants and animals. Transportation of fossil fuels is susceptible to spills, such as what happened when the Exxon Valdez oil tanker ran aground in 1989 in Alaska, covering a highly delicate ecosystem in 11 million gallons of crude oil. This is a major issue when it comes to water as well. While we have large-scale, highly publicized oil spills like the Exxon Valdez and Deepwater Horizon, the majority of oil that ends up in our waterways and oceans comes from urban runoff, specifically from cars. Additionally, the chemical components from fracking, and sometimes the natural gas itself, can get into groundwater and have been known to create flammable water coming from people's taps. The following slide provides you with an opportunity to see how some of these ideas are connected together. Feel free to pause the video and explore the connections between these topics. Then, use the statements at the beginning to review.